When insurance companies establish policies for covering screening tests for diseases, one important factor is the value of the test predicting the disease. For example, for a certain type of disease, insurance companies may only cover the test costs if the test improves the prediction of having the disease by 80%. To help decide coverage policy for a new test, use the following data to help decide whether the test should be covered. So here we're going to use a table to find the exact probability for each of the events here. So in the first case, we're being asked to find the probability of A. Event A is having the disease among everyone. So now to do this, you need to take a look at this first row. This first row tells you the total number of people that have the disease. And it doesn't matter whether they test positive or negative on the test, it's that they definitely have the disease. It's given that 55 that test positive have a disease and 12 that test negative have a disease. So the total number is going to be 55 plus 12, and you have to divide this by the total number of people. Okay? The total number of people, of course, is going to be all these four cells combined. Okay? People that have the disease and people that do not have the disease. Right? So 55 plus 12 plus 22 plus 74. So you do this, and you should have something like this in your calculator. Okay, 945. So we're going to round it to 3 decimal places. About 0.411. So now in this second question, part B here, we need to find the probability of event B. Event B is testing positive for everyone. So what is the probability, let's say, that a random person selected will test positive? All right? And to do this, of course, we're going to look at this first column. It gives you the number of people that test positive, irrespective of the fact whether they have the disease or not. All right, so we have to sum up these people, 55 plus 22, and divide it again by this total number, which we talked about was 55, 12, 22, and 74. And if you do this correctly, you should get this in your calculator. 472, 392, 638. So to 3 decimal places, this is about 0.472. Okay. Now the third event is to find the probability of A and B, okay? These two events happening at the same time, having the disease and testing positive. So we have to look in the table where there's a shared cell between a row and a column, okay? So having the disease obviously is the first row. Testing positive is the first column. So the first row and the first column meet at this number 55, okay? This tells you the number of people that both have the disease actually and also test positive. So we have to take that in the numerator and divide it, of course, by the total number of people, okay? So again, and this total number should be actually 163. Okay, so I might as well just write it smaller, 163. Okay, so if you do this right, you should get something like this in your calculator. 337, 423, 313. So to 3 decimal places, that's going to be 0.337. Okay, so these are the 3 events. Now the fourth event here is the conditional probability. Having the disease given tested positive. So given tested positive, what does that mean? We have to only limit ourselves to a certain part of a sample. So not everything now is going to be involved, but only a small part of the sample. The part that tells you the number of people tested positive. So again, we're going to look at the first column because this gives you the total number of people that test positive. This will be a smaller sample that we're going to pick from, right? So now we're going to have to pick the number of people that have the disease among those only that test positive, not everyone else, right? Not everyone total, but just this first column total. So what is that going to be? Having the disease is 55, and the total number is going to be 55 plus 22, the total number of people that actually test positive. Okay? So if you do this, you should get something like this in your calculator. 714, 285, 714. To 3 decimal places, that's going to be about 0.1714. Now, the last question is kind of tricky, and you should understand really what it means. It says, should the test be covered? What is your conclusion? Justify your answer using the conditional probabilities above. So you should understand, what are you trying to compare? Notice that once again, we can read up here. It says, for a certain type of disease, insurance companies may only cover the test cost if the test improves, okay, improves the prediction of having the disease by 80%. To help decide coverage policy for a new test, use the following data to help you decide whether the test should be covered. So we have to basically measure the improvement of the test and making sure that it's at least 80% improvement versus the general probability. So basically what you're going to test, what you're going to compare is the conditional probability here, okay, probability of having the disease given tested positive versus the general probability of having the disease. Okay? So we have to make sure, we have to measure this being at least 80% improvement, this probability, over the old one. How do you do this? How do you do this correctly? Well, method 1 of solving this is to basically understand what how you're going to express 80% improvement in mathematical terms. So 80% improvement, okay, by the test means that the probability of having disease is 100%, right? The complete total, basically the total previous probability, the general probability, plus an additional 80%, right? Because we're talking about 80% improvement, so we have to add 80% on top of the existing whole 100%, okay, of the general probability, right? So this is going to be the 180% of the original probability, the general probability of having the disease, which is 0.411. Okay? Or basically what it means is that when you're trying to calculate 180% of 0.411, you're going to basically get 1.8 times 0.411. This is exactly going to give you 180% of the previous probability, of the general probability of having the disease. All right, and that's going to give you 0.7398. Now I want you to understand what this result really means. This tells you the new probability of having the disease. This probability is going to be compared with the conditional probability. And the conditional probability was this one, 0.714. So now notice, since 0.398 is greater than 0.714, and 0.714 was the probability, the conditional probability, okay? The probability of having the disease given tested positive. So notice that this probability, 0.714, is the test probability, right? You tested positive, and that's the probability of you having the disease. But the 80% improvement from the general probability of having the disease is 0.7398, right? That's the desired probability in order for the test to be covered. And this probability is greater than the test probability, the actual test probability. Okay, so since it's greater, this is too small. This is not large enough. So that means the test will not be covered. The test should not be covered. Now that's the first method of solving. The second method is to use percent change. Now, how does that work? Percent change means that you're going to take the test probability, the conditional probability, subtract the general probability from it, and divide by the general probability. All right, that will tell you the percent change. And this percent change, you're going to compare it with 80%, right? Because 80% is going to be the percent change that you're actually going to compare this against, right? And you're going to make sure that it's 80% and above. Let's see what this is going to give us. If we substitute all the numbers, we should get part D probability, which was this, 0.714, minus the general probability of having the disease. So that would be what? That would be 0.411. And you divide that by the general probability. And what this should give you is about 0.74. Now notice what this means. This means that the test improves the prediction of having disease by about 74%, right? Because that's the percent change. The test versus the test probability versus the general probability, the percent change is 0.74. Okay? So the test improves the prediction of having disease by about 74%, right? So since 74% is less than 80%, so notice that the test will only be covered by the insurance company if the prediction of having the disease is at least 80%. 74% improvement is 6% less than the required desired threshold number. Since that is true, the test will not be covered. Okay? So I just showed you two different ways, two different methods you could see it to understand how it is possible to estimate whether or not the test will be covered by the insurance company based on the given conditions. Thank you so much for watching. See you in the next video.